Right, Matrix, let's see, what did you do? Okay, the one method that you could use is that I use is I write my little cubic down. So I get x cubed, there's a missing x squared term, minus 3x minus 2 is 0. And remember, I put the little factor there. And then what I would do is I'd say x cubed over x is x squared. I've got a missing middle term, if you remember. Then I say minus 2 over 1 is minus 2. Okay, now remember, this is, if you check, x times x squared is x cubed, and 1 times negative 2 is, of course, negative 2. Now, how do we get that? We connect the x squared term, and it looks like, for me, a smiley face. Okay, so what you could do is you go there, connect those. Okay, that's 1x squared. Okay, and then plus mx squared. I'm connecting, and it looks like a little happy face there. The 1x squared and the mx squared. I always connect the x squareds, and that must give me whatever that x squared term is there, which is 0x squared. And then you drop the x squareds, and you get 1 plus m is equal to 0, so m is equal to minus 1. And you plug it back into there, and you then get it. The other way, some people will use long division. If we go through that quickly, let's have a look at that method. The long division method is quite cool. You go x cubed plus 0x squared. You always put that in anyway, minus 2, and then you do this. Some schools do this here, and you got x plus 1. Then you go x cubed over x is x squared. And then you multiply, if you remember, x cubed plus x squared. Then you sign change, you subtract those, bring that down, negative x squared, bring down the minus 3x, start again. Minus x squared over x is minus 1x, it's like my m there. Multiply it, minus x squared minus x. Okay, sign change, so those vanishes. Minus 3 plus 1 is negative 2x, bring that down, and it goes to negative 2 there. Negative 2x minus 2 is 0. And that, of course, is the method of long division. This is the inspection where you connect the x squared. So whatever method your school uses, you need to do that. And you will always get one of these somewhere in the paper. Okay, so that's great. So here we go. So we've got our cubic equation solved. Now I'm using the little smiley face. Remember, you always test these numbers. The ones that work are absolutely wonderful. And this one works. Remember, make a factor. What I do is don't forget the 0x squared, and then you say x cubed over x is x squared, minus 2 over 1 is minus 2. Connect the x squareds, 1x squared, mx squared equals the 0x squared, and then you get your m's equal to minus 1. You'll see that's the m there if you're using long division. Some people also use synthetic division as well, that you can do as well. That's not as usual as the long division or the smiley face method. Okay, so let's continue with this now. Okay, I hope you master all this technique of long division or smiley face. Okay, I like the smiley face method. Okay, so let's move on. And if we look at that, well, now we've actually factorized it. Now you can factorize the trinomial inside, and that's easy. X minus 2x plus 1, no problem. And you've got a repeated x-intercept there, or x is equal to 2. And don't forget the coordinate form, minus 1, 0, 2, 0. And there we go. So that's really what you're doing. Your y-intercept, you let x be 0. Your x-intercept, you're going to let y be 0. And inevitably, you'll have a cubic equation to solve. They love this sort of thing. Okay, now let's have a look at this. Now, what's the next thing? This stationary point. And what do you know about a stationary point? At a turning point, the gradient is 0. Okay, you've got it. Be my hero and write the 0. Here we go. F prime x is equal to 6x squared. You differentiate that. Bring down the 3. 2 times 3 is 6. Subtract 1. This rule, remember the derivative here is minus 6. And if negative 4, it goes to 0. Okay, and then what do? We put it equal to 0 because at a turning point, the gradient is 0. Okay, great. Now here we go. Now we can solve for x. Divide by 6, and x is plus minus. Remember, difference of 2 squares, or you can say x squared is 1, x is plus minus. So now we've got the x values of the stationary points. How do we get the y's? By subbing into the original. Okay, here we go. Okay, so we've got the x is negative 1, plug back into the original. No, remember, it's always the original. And that comes to negative 2 plus 6 minus 4, which of course is 0. Okay, so and then we go 1, plug in 1, 2 times 1 cubed minus 6 times 1 minus 4, and that comes to minus 8. So there's your stationary points. Okay, so you've got those points there. Okay, so remember y-intercept, x-intercept, let y be naught, and then stationary points or turning points. Differentiate, let's go back and check that. The derivative there, you get the derivative, solve for x, take those two x values, plug them back into the original. There you go, get your y values, and you now have your two stationary points. X is -1, y is naught, -1, -8. Okay, now, people, once we've got that, we could also get a point of inflection, and I'll show you this, is if you differentiate twice, there's a much easier way. If you differentiate twice and you put it equal to naught, x is naught, and the point of inflection is naught, -4, because obviously if x is naught, the whole thing goes there. Now, I want you to try and draw this graph for me while we go to the ad break, and let's see if you can get this right, okay? Don't worry, we'll come back to point of inflection. Stay with us on Matrics Uploaded.